Hey, welcome to Chapter 2B. This is the one and only video for 2B. Feeling kind of sad because it's me, Mrs. Feliniak, all by myself, so I'm riding solo on this one. We're going to get started with the math humor. The question is, why is the math book so sad? And the answer is because it had too many problems. It's a good one. All right, you guys. Let's get serious here. In this part, we're going to take our proofs to the next level. We're going to start talking about deductive reasoning and their properties that go along with all of this. And then we're going to actually do a proof at the end of the note. So, deductive reasoning is just simply a process in which the conclusions are drawn logically from the given information. So, if something happens, then logically this is the result of it. The lengths of the segments of the measures of the angles are going to be real numbers in this case. And all of these are going to be used in the following properties. So we got real numbers, all going to be used in the following properties. Properties of equality. These are used to explain why the steps in algebra are allowed for these real numbers, A, B, C, D, so on and so forth. The following are going to be true. So the first property is the reflexive property. Reflexive property is really easy to remember. I like to think of reflection. What you see is what you get. This is when you say something equals itself. So this is something is equal to itself. So whether it's just something simple like A equals A, or a segment MN equals MN, or the measures equal each other, or an angle equals itself, reflexive property is just simply something equaling itself. All right, your next property is the symmetric property. Symmetrical meaning same on both sides. This says if A equals B, then B has to equal A. Okay, so that says if two things are equal to each other, it doesn't matter which side of the equal sign you have them on. If they're equal, they're going to be equal. So if angle A equals angle B, then B also has to equal angle A logically. The third one, the transitive property, seems pretty confusing, but actually it's going to be one of the easiest ones we do. I like to think of this as cutting out the middleman. So this says if A equals B, and then that B here equals C, then logically A also has to equal C. I cut out that middle guy. It was the branch, it was the bridge from A to C. So if you take a look, I said if AB is equal to CD, and then CD here is equal to KL, well then AB has to equal KL. The next few properties are going to be really easy for you to remember. The first of which is the addition property. The addition property says if you add something to one side in order to balance it, you have to add it to the other side. Okay? So here it's a little bit confusing with our variables. But if A equals B and C equals D, well, C and D are the same thing, right? So if I add the same thing to both A and B, it still makes the equation equal. You see this a lot in these algebraic problems where you have to solve for x. If you take a look at this problem here, it says if x minus 4 equals 9, then x equals 13. Well, in order to get there, we had to use our addition property. In order to get there and solve, we had to add 4 to both sides. This process of adding the same thing to both sides is your addition property. The next property is the subtraction property. Again, a little bit confusing with our variables here, but it's the same concept. It's saying if A equals B and C equals D, meaning C and D are the same thing, if I subtract the same thing on both sides, it keeps the equation equal. It balances the equation. Again, you see this a lot when it comes to solving for x or solving for your variable. If I've got x plus 28 equals 52, and I say that x is 24, in order to get there, you had to subtract the 28 on both sides. This process of subtracting the same thing on both sides is what makes the subtraction property. The multiplication property, also a little bit confusing with our variables. It says if A equals B and C equals D, then A times C equals B times D. Again, it's the concept of multiplying by the same thing on both sides. Again, here, If 3 equals x and y equals z, if I multiply both sides by y and z, they're the same thing. It balances the equation. You see this a lot when it comes to solving for x when you have a problem like x over 3 equals 6, for instance. If you wanted to solve for x, you would have to multiply by 3 on both sides. This process of multiplying by the same thing on both sides gives you the multiplication property. The last one on this slide, you guys, is the division property. The division property follows the same suit as the subtraction, addition, and multiplication properties. Again, it's this process of dividing by the same thing on both sides. So for here, if I have 2GH equals 12, and then I tell you that GH is 6, well, in order to get there, I divided both sides by 2. That process of dividing both sides by 2 by the same number gets you the division property. All right, the only one on this page is our substitution property. Substitution, you guys should know this word pretty well. Substitution means to replace one thing with another. So if A equals B, then A and B may be substituted for each other in any equation. A lot of times you see this in an algebraic problem where they say, for instance, y plus x squared is greater than 7. If they tell you that x is 3, you're going to take that 3 and plug it in for x. This process of plugging in for something else is what makes the substitution property. All right, these next two properties are very similar, kind of can get confusing. You just have to remember that they have the same concept. It just depends on if you're dealing with two or more than two numbers. The commutative property says a plus b equals b plus a, and a times b equals b times a. This says if you have two numbers, it doesn't matter how you add them, you're going to get the same answer. Or it doesn't matter how you multiply them, you're going to get the same answer. So for instance, 1 plus 3, which gives you 4, is the same as 3 plus 1, which also gives you 4. And then multiplication-wise, for instance, 2 times 4, which gives you 8, is the same as 4 times 2, which also gives you 8. All right? Now this is also saying x times y equals 4, so 4 equals x times y. I told you that these two things are equal, so it doesn't matter which side of the equal sign that they're on. It's saying that no matter what you do, no matter how you multiply these, they're going to be the same thing. The associative property follows the same type of rules. It's just if you deal with 3 or more numbers. So this is with 2 numbers, this is with 3 or more. So for instance, if you take a look at the examples here, we have a plus b plus c equals a plus b plus c. And then a times bc equals ab times c. I know it sounds confusing, but think about it. Let's say I've got 3 numbers. 1 plus 2 plus 3. This gives me 6. It's the same as if I were to do 1 plus 2 plus 3, which also gives me 6. Same thing with the numbers. Let's say I have 2, 4, and 1. Okay? If I take 2 times 4 times 1, this is 8. And if I go the other way, 2 times 4, and then times 1, it also gives me 8. These properties follow the same rules. It's just it depends on how many numbers that you're multiplying or adding. The very last property, the one that you should know very well, is the distributive property. This is when you take your number and distribute it to each number inside. So a times b plus c here in the inside, a has to be multiplied to each part of this in order to make this work. So if you take a look at my example here, I have 3 times x plus 6. 3 has to be multiplied to each term here in order to actually come up with our answer, 3x plus 18. Okay, we're going to use these properties to help us actually do our 2-column proofs. So get to know these. You need to study them. You need to know them very, very well. All right, there are 2 examples actually here, you guys. The first one is up here. It says, which property allows you to conclude that the following is true? Measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 1. Well, I have 2 things here being added to each other, and I'm saying it doesn't matter which order I add them in, I'm going to get the same answer. Hopefully you realize that this is your commutative property. Okay? The next one says solve the equation and then justify a justification for each step. Well, solve this like you would algebraically. What's the first thing that you would do to solve for m? Okay, hopefully you said you'd add 8 to both sides. Okay, when I add the same thing to both sides, which property is that? That is the addition property. Okay, so after this, I get 4m equals -4. So now what do I have to do to solve for m? Hopefully you said I had to divide by 4. And if I divide by 4 on both sides, that is the division property. And you get your answer is m equals -1. I would like for you guys to do this next proof on the next slide by yourself. This is the one I was just saying I would like for you to do by yourself. I'm going to get you started off because there's one step that we started with that I didn't show you in the last one. The first step is always going to be, what did they give you? Well, it says justify each step in the following. The following is what they gave you. They gave you this. So that's going to be your first step. Step number 1, you're going to write down your problem. 3x plus 5 all over 2 equals 7. This will always be the given. Your first step is always the given. So now, just like we did the last one, I want you to go through each step on how to solve this and write each justification for those steps. All right, you guys, hopefully on the left-hand side, this is what you wrote. You should have gotten x equals 3. Now the question is, how did you get that? So what are your reasons? Well, if you take a look from step number 1 to step number 2, in order to get this, you had to multiply both sides by 2. So step number 2, you should have had written down the multiplication property. Okay? From step number 2 to step number 3, you had to remove 5 on both sides. So that process of subtracting on both sides, you should have written down the subtraction property. And this last step, from step 3 to step 4, we had to get rid of the 3. So we divided by 3 on both sides, and we got our answer as x equals 3. So in order to get to step number 4, we had to use the division property. Okay? We just did our first proof. I'm hoping that you're realizing that this isn't as scary as everybody makes it out to be. It's a little bit of work, but as long as you know your properties and as long as you practice, you should do just fine. Make sure you guys do your whisk, and we'll see you guys tomorrow.